If you have it looking correctly. A lot more to work with here, but how does the initial setup look? Everybody okay there? Okay. All right. Now let's get this thing multiplied out. All right, so I've got my cube here. That would be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus, distribute the 2x minus 2 delta x. Then distribute the negative, minus x cubed plus 2x, all over delta x. How's that looking? Sometimes the cube, I know, can be a little bit painful, right? As far as what happened when the cubed out would be that you go through, you have really two choices. You can write it 3 times, right? If you write it 3 times, and you multiply 2 of them, get your answer, then multiply by the 3rd. So kind of tedious. What I'll use is what you learned before was Pascal's triangle. There's my coefficients. 1, 3, 3, 1. We have 1, 3, 3, 1. First one counts down, cube, square, 1, nothing. Second one counts up, nothing, 1 of them, 2 of them, 3 of them. Remember doing that? Probably been a while. I can promise you this, you're not going to see much of. I'm going to load you up on the test with 3rd and 4th powers for you to multiply all the way out. And you get the general idea. Okay. All right, so as far as simplifying, what goes away? There's 2x, x cubed. That's about it, huh?
Yep, but now everything can cancel with the delta x on the bottom.
Right, everything's got a delta x. I can take a delta x out. Everybody agree?
Yes.
All right, so here we go. Limit. Delta x approaches 0. 3x squared plus 3x delta x plus delta x squared minus 2. Again, I just went across the top, took a delta x out of each one. That makes sense okay there? Okay, now let's finish the limit. Now I can substitute 0 for delta x. I can substitute 0 for delta x, and when I do that this time, substituting 0 for delta x, I get 3x squared minus 2. Everybody agree with that? The other 2 terms go away? Make sense? Okay? There's my derivative. So this means that f prime of x is 3x squared minus 2. Okay? Again, just working with some notation. Yes, the derivative is just 3x squared minus 2. Just working a little bit, introducing that notation there. Okay there? All right. Okay, now let's change this just a little bit. Found the derivative. Now we're going to say find the equation of the tangent line to f of x equals 2x squared minus 3x at 1 comma negative 1. All right, so there's my setup. We want to find the equation of a tangent line to that function. So in your mind, you're thinking, all right, 2x squared minus 3x, I've just got some parabola there. Does that make sense to everyone? And I'm going to go to the point 1 comma negative 1 on the parabola, and I want the equation of that tangent line at 1 negative 1. That's what I'm looking for. Okay. I don't need a picture of the graph. Of course, I can go on my calculator and get a picture of that graph, but we have the general idea. That's really all we need. I've got a parabola. There is a point 1 negative 1 sitting on the parabola. I want to find the equation of the tangent line going through that point. Everybody okay there? So mentally, I'm thinking something like this. I'm not saying that's the point, but I'm looking for that line. I want that equation of that line. That's kind of what's going on. Okay. All right. So this is going to mix in some old algebra stuff. Equation of line. I don't care what kind of line it is. Call it a tangent line, a secant line, just some regular line. It does not matter. The equation of a line comes from y minus y1 equals m x minus x1. That was your old point slope form of a line. This was that point slope form from algebra. So I know it's been a while since you've used it necessarily, but that's not new. Everybody agree with that? You've seen that somewhere before? Okay. Now, matter of fact, that's where the slope formula came from, because if you want to get m alone, wouldn't you divide the x's over?
Yes.
That's why it's called the point slope form. That is your old slope formula. You divide the x's over. So, y plus 1 is m x minus 1. Why did that one change to plus 1?
Because it's minus.
Yeah.
Yeah, that's my y value is negative, right? It should be minus a negative. I agree with that? So I've got an old equation there, old point slope form. Maybe a little out of practice, but once you write it down, it's like, all right, I've seen that. I can throw my point in. I know my point's 1, negative 1. So I've got my x and my y value. Good there. Now I just need the slope. Okay? I need this guy right here. M slope, right? The slope of the tangent line is the derivative. So we're going to go through it, but let's say my derivative value is 2. Then I would have y plus 1 equals 2 times x minus 1. My derivative value is negative 7. Y plus 1 times equals negative 7 times x minus 1. I need that derivative piece. That's going back into what we've got today. So here comes the derivative. So my derivative, which is the slope of the tangent line, limit delta x approaches 0 of 2 times x plus delta x squared minus 3 times x plus delta x minus 2x squared minus 3x all over delta x. So I had x plus delta x going in for x. So x, I've got 2 x plus delta x squared minus 3 x plus delta x minus my function and over the delta x. Setup looking okay. Painful part is going to be the multiplying and kind of simplifying it out. So if I multiply this first part out, I would get 2x squared plus 4x delta x plus 2 delta x squared. So I'd be multiplying this binomial out, then distributing a 2, minus 3x minus 3 delta x minus 2x squared plus 3x all over delta x. Now you can get that down. You know how to multiply. You might need to go back and practice a little bit, but you haven't done tons of it lately. But make sure you're seeing where the pieces are coming from.
So where does the 2x squared minus 3x come from again? Oh, that's the, yeah.
That's the function.
So why is that in there though?
Minus f of x.
Oh, right, sorry.
Minus f of x, so there's my function piece. So I've got f of x with delta x, so this is that first part. So again, put it like this, there. So this front part, this can help you in your notes too. That's f of x plus delta x, and then this is that f of x. There's my two pieces there. Everybody else okay to this point? Looks ugly, but we got to simplify it down. So let's see, the 2x squares go. The 3x's go. Does everybody agree? And what you've noticed so far is you always get something that cancels. And if you look at what's left, there's a delta x that comes out of each one. Everybody agree? All right, so I'm going to rewrite it without the delta x. Limit. Delta x approaches 0 of 4x plus 2 delta x minus 3. You good there? Okay, so now as delta x goes to 0, what does this equal?
4x minus 3.
4x minus 3. Pretty good there? All right, so this is what we're referring to here. What this means is 4x minus 3 is the slope of tan at any point, anywhere on the graph, any x value, that's the slope of the tangent line. I want to know about at x equals 1. At x equals 1, 4x minus 3 equals 1 in this case, because I have 4 minus 3. Now, why did I say at x equals 1? That's the x value I was looking at. So now my slope's 1. Here's the rest of your equation. There's the equation of the tangent line. Now you can simplify it. You can distribute the 1, move it over. I guess if you did that, you would actually end up with y equals x. I don't care what form it's in. But that would give me that equation of the line. So the bulk of the work here, new work anyway, would be working this limit function to get that derivative value. That would be the bulk of it. Nothing in that is new per se, just a different look. Okay, definitely more confusing. Got to do some simplifying there. That's going to be where most of the work's at. Again, if I had changed this to, let's kind of make a change here. Let's say that this is the point. And watch what happens. 2. And let's see, that would be 8 minus 6 is 2. So that would be at the point 2, 2. So now this is minus 2, minus 2. Everybody agree with that? Nothing's really changed on my process. Minus 2, minus 2. Sure changes my slope though. It's not going to change any of the work I did over there though. because this was the slope at any point. If I want x equals 2, slope would be 5. Well, that's the equation with tangent line. It doesn't matter what the function is or what point. This is the bulk of your work, getting that derivative, that slope of that tangent line. That makes sense to everyone? Okay, let's get to your assignment.